I'm Anil Kumar. Welcome to my series on providing you solutions for the previous test paper. We have taken up GCE, Advanced Level Paper, Pure Mathematics. Here is question number 12. The value in pounds for pounds V of a vintage car T years after it was first valued on 1st January 2001 is modeled by the equation V equals to AP to the power of T, where A and P are constants. Given that the value of car was 32,000 pounds on 1st January 2005 and 50,000 pounds on 1st January 2012, find P to 4 decimal places. Show that A is approximately 24,800. Part B is, with reference to the model, interpret the value of the constant A, the value of the constant P. Using the model, part C is, find the year during which the value of the car first exceeds 100,000 pounds, right? So this is fairly straightforward. Let's try to substitute the values given to us and find the solutions to 4 decimal places for P first. So this formula is valid from January 2001, and on 1st January 2005 the evaluation was 32,000. So 2005 minus 2001 is 4 years, right? So from this given information we can write T equals to 2005 minus 2001, which is 4. Substituting 4 here for T, the value given to us, we get one equation, and this equation will be 32,000 equals to the amount, which is A, and then we have P to the power of 4, right? Now the second equation is 50,000 for 2012. So 2012 minus 21 will give us 2001 is 11, right? So here T is equal to 11, correct? So we'll use the second equation, T equals to 11, to get the second equation. The value is 50,000. So we have 50,000 equals to AP to the power of 11. Let's call these as our equation number 1 and equation number 2. So if I divide one by the other, that's to equation 2 divided by equation 1, so we get 50,000 divided by 32,000 equals to A and A cancel, right? So we get, let me rewrite and then we'll cancel. P to the power 11 over A, P to the power of 5. So let's simplify. The right side for us is 50 divided by 32, which is 25 over 16. A and A cancel. P to the power of 11 minus 5, which is 6 for us, right? So we get this as sorry, this is not 5 but 4. Okay. 11 minus 4, which is 7 for us. So we get P to the power of 7. So from here we can find the value of P. So P will be equal to 7th root of 25 over 16. Clear? So let's find the power as 1 divided by 7. So that gives you a value which is equal to 1.06583. So we get a value of P which is 1.06583. Now find P to 4 decimal places. So we are going to write to 4 decimal places. So the value of P will be equal to 1.0658. So that is what it is. So normally the solutions will be provided in this space. However, since I want to keep focus on the questions in all my solutions, I have shown you solutions at the most convenient place to explain the idea, right? Okay. Now, once we find the value of p, we can also find the value of a. So you can use any one of these equations. We can say a is equal to first equation, 32,000 divided by the value of p, which is 1.0658 to the power of 4. Okay. So what we get here is 32,000 divided by, within brackets, 1.0658 to the power of 4, which is 24,799, right? So this can be, as written here, approximated to 24,800 pounds. Okay? So we have shown that A is approximately equal to 24,800 pounds. Okay. Now, with reference to the model, interpret the value of constant A and the value of constant P. Now, clearly, from this, A is what? If you read the very first sentence, it says the value V of the vintage car T years after it was first evaluated on 1st of January 2001 is modeled by this equation. So the value of A is actually the value, I can say, on 1st January 2001, correct? That is what it is. And P is the rate at which it is growing, right? So growth rate. So the value of P, which is equal to 1.0658, indicates that there is 6.58%, you can say, growth or appreciation per year since 2001. You can say January 2000. Is that clear to you, right? So that is how we can interpret the values of A and P. Okay. Now let's look into part C, which is find the year during which the value of the car first exceeds 100,000, right? So let's use the value which we got. We'll approximate to 24,800. So we'll use the formula now we want this final amount to be, we'll use the formula, this A is 24,800 and the value of P is 1.0658 and the power will be T, right? Now we want to find the year when it exceeds 100,000 for the first time. So let's substitute 100,000 here for V, and then we'll find what T is. Correct? So it'll be 100,000 divided by 24,800 equals to 1.0658 to the power of T. So let's calculate how much this is. So we have 100,000 divided by 24,800. That is 121 over 31. So we get this as 125 over 31. Now that's what we get, right? You can also write the decimal value for this, which is, well, we'll use this 125 over 31 since that's a recurring value. Okay. Now how do we solve this? To solve this equation, we should take log both sides. So we'll take log both sides. We say T log of 1.0658 equals to log of 125 by 31. So that gives you the value of T as equal to log of 125 over 31 divided by log of 1.0658, right? Okay, so let's do this. We have log, you can use log or ln, divide by 31, and then we'll divide this by log of 1.0658, that gives you 21.88. That means the value of t is more than 21, right? So it is